All right, describing a function. There are many ways to describe a function. Here are some examples. Functions can be given by a formula. For example, f of x is equal to x plus 1, or the function f such that x in the domain is mapped onto x plus 1 in the codomain, where x is an element of the set of real numbers. So a function may be described as a formula. A function can be given as a graph. So f of x can be a graph. F of x would be a linear graph. A function can be given by listing its values. So f of 1 is 3, f of 2 is 5, f of 4 is 7, etc. For a function can be given as a set of ordered pairs, and we have discussed that already. So the ordered pairs would be like 1, 3, 2, 5, 4, 7. Those are your ordered pairs. The first element in the ordered pair is the domain element. The second element in the ordered pair is the codomain element or the range element. Now, a function can be represented by an arrow diagram. We're all familiar with that. All right, we're going to do example 3, but before that, we can look at the try-these 6.1. And in try-these 6.1, we're asked which of the following relation is not a function. Give a reason for your answer. All right, so looking at try-these 6.1, we're asked which of the following relation is not a function. Give a reason. Well, A is a function because every element in the domain is mapped to what? One and only one element in the codomain. You can see that in the fact that one arrow is leaving every element in the domain. B is not a function. Now, B is not a function because E in the domain is not mapped to any element in the codomain. So in other words, that E in B disqualifies B from being a function. Because in other words, E is the value in the function B for which the function is undefined. Because the definition for a function says that every element in the domain must be mapped to an element in the codomain. E is not being mapped to anything. E has no image in the codomain. Therefore, B is not a function. C is also not a function. Reason, 1 in the domain is mapped to 2 elements in the codomain. And by definition, that is not a function. Because a function is a relation in which every element in the domain is mapped to one and only one element in the codomain. So since 1 in the domain of C is mapped to 2 elements in the codomain, C is not a function. Example 3. Is f of x equal to the root of x a function? Well, let's just try something. Here's what the answer basically to this question is no. But let's look at something. When let us say x is equal to 9, f of 9 would be equal to the square root of 9, which would be positive and negative 3. So in other words, if I drew a mapping diagram or an arrow diagram of this function, 9 in the domain would be mapped to 2 elements in the codomain. 9 would be mapped to what? 3. And 9 would also be mapped to what? Positive 3. It would be mapped to -3 and positive 3. So 9 in the domain would be mapped to 2 elements in the codomain. Therefore, f of x is equal to the root of x is not a function. That's one way you could look at it. So 9, if you need to write a statement, 9 in the domain of f is mapped to 2 elements in the codomain. Therefore, f of x is not a function.